That is the reason to come into physics, to help solve some of the basic mysteries that we have today, but then to learn all of these tools that you can just apply to anything.
Patrick, can share us your stories, how you involved to the physics study and now becomes one of members in gravitational wave.
If I think back to how I got started, the interesting thing is that I grew up actually as a child in the time when black holes were first an idea, and this just fascinated me as a kid. And so as I grew up, I wanted to learn more about Einstein, and then I learned about the mathematics, and I got the opportunity then to go to Caltech back in the mid-90s when LIGO, the Laser Interferometer Gravitational Wave Observatory, was just really beginning to be built. And Kip Thorne convinced me that it was an interesting project to work on. And so I started trying to figure out how to measure the waves from the data that would be taken. And back then, the group at Caltech was rather small. There were maybe 100 people at Caltech. And there were maybe 200 people around the world working on LIGO. Now there are 1,600 people working on LIGO.
Yeah, 1,000 including Taiwan.
Yes, including Taiwan. And Taiwan has, I don't know how many, but probably 30 or so members. So, which is quite large as a single country, actually.
Then you mentioned Kip Thorne convinced you.
Yes.
So I'm curious about how they changed your careers, in some sense.
I still remember when Kip Thorne offered me a postdoc. In it, it was in 1995, and he wrote to me, he said, your postdoc will be ending around the time that LIGO is operating for the first time, which was 1998. So it was a field that we really didn't know how quickly it would move or how much work was ahead, but it was exciting, and the opportunity to be part of the team that would first measure gravitational waves was really very exciting, and so it was very motivating.
Then we go to the 2015. So then eventually, you very first really observed the signals from the universe.
That's right.
Very far away.
Yes.
And what's your personal experience, and what at that time the excitement, atmospheres in the groups?
I was walking up the hill in a park very close to my house on the way to the university, and I realized I was sort of smiling. I just and I wondered, why am I smiling so brightly? And then I realized, I was like, wow, we've detected gravitational waves from a pair of black holes, these things that I've been thinking about since I was 10 years old, that collided with each other a billion light years away. We needed to check that nothing had gone wrong with the detectors and that this was real. So that took a lot of checking. So,
to make sure that nothing goes wrong.
Exactly, yes. So, yeah, very exciting time.
From that time, it's 01 observation phase.
Yes.
Then now we are just finished the 04. What discovery site and or the instrument site, the improvement and sensitivity, and more accumulate more and more events. Can you say something about this phase from 01 to 04?
There are so many subsystems to those detectors that what you do is you install them in phases. So you put in the fundamental pieces, then you make the next pieces to make it slightly better, and you continue that. And so when we started observing in 2015, we had reached sort of a first milestone of sensitivity, but we knew that we would need to keep improving the detectors by commissioning new subsystems every few years. Nowadays, We see about 1 every 3 or 4 days
Wow.
when we're observing. We don't know what 70% of the universe is made of. We call it dark energy, but we don't really know what it is. So right now we're actually in this funny place where we have these theories that all work very, very well in their independent spaces. We can build these incredible technologies, we can make computer systems, we can measure quantum effects in the laboratory, and yet our explanation of the universe as a whole has these huge mysteries. 70% of it, we don't know what it is, right?
But so, can gravitational wave resolve this?
It can help resolve it because ultimately we can use gravitational waves to measure the expansion rate of the universe. That's one of our key science goals. It is an exciting field, and it's one where I think young people have a really opportunity. There's just so many things to do and so many places to contribute. And one of the things that's also true about it is that it's not a place where you have to just be some mad scientist with a white coat and big hair. Or it doesn't have to be that way. You can come, you can work on this exciting field and learn some real exciting technologies and help improve those technologies, and even bring those technologies back to industry. And so it's just a way to really learn new things about the world, but also to contribute to how the world is improving and getting better.
That's very true.